For experiment 10, I will be explaining the titration process for this experiment. So, in this experiment, normally you'd have a beret filled with your titrant, in this case sodium hydroxide, which is a colorless solution, and then you would have your Erlenmeyer flask that would be tapered kind of like this, but at a greater angle to make it easier to swirl without spilling. And you'd have your analyte in there, which in this case would be um, hydrochloric acid. And the point of the titration is to almost like a balance, right? So um, you're trying to balance the acid with the base, the titrant usually being the base. Um, and since I don't have a puree, what I did to just get small drops to simulate the drops of titrant going into the analyte is I have this like wet rag right here, and if I squeeze a little bit, you get a drop, a drop, a drop, and as you do this process, you'd actually see um, the indicator, the phenolphthalein change color based on how much of the acid is being neutralized, right? So the indicator is going to change color when it reaches a certain pH, which is close to the balancing point for this titration. Now, of course, because this is in the actual experiment, you're not going to see it change color. However, if we were doing this experiment, you'd get a solution that has a faint color to it, right? And that color would actually slowly fade away over time if exposed to carbon dioxide, as it would create an acid in there and change the color, or change the pH, therefore changing the color. But this would indicate the balancing point, right? And then however much of the sodium hydroxide was used to neutralize the hydrochloric acid is or it would show you the concentration of the analyte, in this case hydrochloric acid. Now, of course, you would have slowed down the process of adding drops um, towards the end, as it would take a longer time to change back to the clear color. But of course, if you added too much, you'd overshoot and end up with something like this, which, as you can see, is actually a much darker color than this, which means you overshot with the amount of titrant being added to the analyte, and you couldn't use that volume reading to determine the concentration of the hydrochloric acid. So that's how you would do a titration. For example, if we had 40 milliliters of 0.11 molar sodium hydroxide, and we wanted to perform the titration on 22 milliliters of hydrochloric solution, you would use the amount of sodium hydroxide, use the relationship with the molar, right, amount of sodium hydroxide to get it over liters, so you could get it into moles. The ratio of hydrochloric acid to sodium hydroxide is moles is 1 to 1, and then you divide by the liters of hydrochloric acid, so you could get the molar of the hydrochloric acid. And if you were to work it out with these numbers, you would get exactly 2 molar hydrochloric acid solution.